Hey, what is up, you guys? This is Justin. Gonna thank you guys for making me part of your day. Gonna be bringing you guys some college algebra, trigonometry, linear equalities of one variable. So I used to write the date, and now I'm not gonna write the date because I don't know which order these are gonna go into. So there's a few things that we're gonna be talking about today. The big one, if you're where I taught, this was if you go on a normal track, it goes algebra one, geometry, algebra two, college algebra, trigonometry. So it's basically pre-calculus. So this would be a senior level. This thing's in the way. So it's basically a senior level math class. But I was surprised because there was all stuff that students they never really figured out, and it was really easy, but they just never taught them that. I guess they skipped that part. So we're going to talk about inequalities. Inequalities means not equal, right? Okay, so, or unequal. So what we're going to do is that we're just going to graph x is greater than or equal to 1. Okay, now here's the thing. You probably know how to graph this, and that's fine. That's easy. But you might not know how to put it in interval notation, which is strangely really easy, but a lot of students don't. A lot of students just don't do it. They just don't know how to do it. Or they know how to do it. They just were never taught this how to do that, all right? So as you know, this is actually an 8th grade problem. So you have your element in the set 1. So it's going to be, you circle 1, right? Now you got to figure out if it's open or closed. Since there is an equal sign underneath it, I'm going to put this right here. Close it. And you want all the numbers that are bigger than 1, which is going to go in the positive direction. Positive always goes to the right. Okay. Now, the thing that they want you to do is put it in interval notation. And I'll give you some few quick hitters on this. Interval notation. Now, they kind of write it funny. They say x is an element of, and here's what you need to know right here, okay? There's two things that you use. You're either going to use parentheses or you're going to use brackets, okay? Brackets in this case is going to be where it's 1 because it's filled in. So you're going to write it like this, like a bracket. And then you're going to put the element, which is 1. And you're going to denote that it goes in the positive direction to infinity, okay? So right here, and you can't, here's the thing. It's bounded and unbounded. So this would be unbounded and this is bounded too. You can't bound infinity. So this would be the interval notation and this would be the graph right here, okay? So now we'll do a few other variances, and we'll just make them up really quick. So let's say, I won't use the ruler for this one. So let's say you had we'll use 1 still, right? So here's 0, here's 1. Let's say that it was opened, positive direction. So the interval notation would be x elements unbounded 1 to positive infinity, like that, okay? So as you can see in these two right here, this is open, right? So that's why you put in parentheses. This one's closed. That's why you put a bracket right there. So let's go ahead and kind of change it a little. Let's say it's just a breakfast. Ooh. Let's say it's that one right there. So x elements. But here's the thing. When you do read this one right here, it's going to be a little bit different, okay? We actually always read it left to right. Okay, so even though it's going negative infinity right here, or it's starting from negative infinity, it would be an unbounded negative infinity to 1, and since it is closed circle, it would be a bracket right there. Okay. So that's the thing you got to remember, is that we read this from left to right, and so on. Okay. And then we'll just do, you would rarely see this, but let's say it was this would be x elements, I don't know, it would be bounded at 0. So it would be closed at 0. Or closed, that's a better term for it. Closed at 0 and then open at 1. Like that. Okay? So that's one of the things that when I taught this is that a lot of students they never learned that. So that's something that you got to take into consideration when you're doing interval notation right there. Okay? We're going to skip a lot of stuff because before I was teaching all of the entire lesson. We're just going to go through kind of just some solving and graphing stuff right here, okay? So snapshot that if you need to. We're going to move on to page 2. We're going to do example number 2 right now, okay? All right, example 2, and it's going to be solving an inequality right here. Now I'm guessing you guys, if you passed Algebra 1 and Algebra 2, you already know some of the rules, so we're not going to go over those. I'll show you them, but we're not going to go over them right now. Okay? Why did they do that? Yeah, I don't know why they do that. Whatever, we'll do that. I would never do it this way, but 2 plus 1/2. I would just add the fractions. They multiplied by the least. Okay. So here's what you have. You have negative 2/3 x plus 1/2 less than or equal to 5/6. Now their move is to multiply. I would just do the fractions and so on. And I would just subtract 1/2 and then multiply by negative 3/2. But a lot of students don't like to do that. So what we're going to do is we're going to multiply by the least common denominator. Look at all the denominators right here. You got 3, 2, and 6. The smallest denominator both of them can be is 6. So we're going to take this, multiply by 6, multiply by 6. Okay. The point is to get rid of all the denominators. All right. So when you do this part right here, this will be 6 times 5 is 30. 30 divided by 6 is going to be 5. It actually just cancels out right there, but I wanted to show you guys that. All right. This one's going to be 6 times 2 is negative 12. Negative 12 divided by 3 is going to be minus 4x. It's actually minus 4 with the x tacked on. 6 times 1 is 6. 6 divided by 2 is going to be plus 3. Okay, so you have that as your new inequality. You're going to subtract 3, keep it the same, keep it tight. Negative 4x, or negative 4x is less than or equal to 2. Here's the thing. When you divide by negative 4, you guys already know what happens, right? Because you're too advanced. If you multiply or divide by a negative, what actually happens is that the inequality is going to flip. So instead of being less than or equal to, it's going to be greater than or equal to. And this is going to be negative 1/2 right here. Okay. So this is going to be the inequality. What we're going to do right now is that we're going to graph it. Okay. But we're going to do that. We're going to graph it, and then we're going to put it in interval notation. So 0, 1, negative 1 right here. So we're about right here, negative 1/2. And let's see. Circle the element. It's going to be closed because there's an equal sign right there. X is greater than, the greater than direction is going to be in a positive side. So right here you would write x elements closed at negative 1/2. And we want to say to positive infinity, which is going to be that. So actually your answer is this. This is your entire answer right here. Okay. All right, what do we got here? Empty sets. Okay, we'll solve one where it's not possible, and I talked about this in another video. We'll talk about empty sets. Okay, so pause it on that one. If you need time to do that, we'll go to example 3. We'll do a quick one right now. We'll solve 7 subtract 3x plus 5 greater than or equal to 2x minus 4 minus 5x. Like I said before, you got to double check these. When you get to this level of math, you want to double check everything and make sure that everything is correct. Because if you don't copy the problem down wrong, you're obviously going to be wrong. I guess theoretically you could be right, but you'd have to mess up to make it right, and you don't want to mess up to make it right. Okay, so what we're going to do is this. We're going to clean up both sides first. So let's work on this left side. There actually is a 1 right here. That's the negative right there. So what we're going to do is change every sign in here. So the next step is going to be 7. Negative 1 times 3x is going to be minus 3x minus 5. Okay. Then we can clean this one up. This will be 2x. 2 times negative 4 is going to be minus 8 right there. Okay. Now, we got to gather our evidence. That's what I was saying in the other video, right? We got to combine like terms. You got 7 and you have a negative 5, okay? So negative 3x slides out to the side. 7 minus 5 is going to be plus 2. Then you have 2x and minus 5x, so it's going to be minus 3x minus 8. Okay, so we're getting close. We're almost there. Now, what's going to happen is I can already tell that something wrong is going to happen right here. Okay? I want to get x's. I usually move them to the left side. So instead of, well, you'd add them on both sides. But in this one, it's going to be plus 3x plus 3x. Those go away. Those go away. So you have 2 is greater than or equal to negative 8. Okay. Now here's the thing. When you read this out loud in your head, read out loud in your head, right? When you read this out loud, this says 2 is greater than or equal to negative 8. Here's the thing. That will never happen. So this is never. Okay. Now, it's not that there isn't a solution, but what's going to happen is that they're going to ask you to graph that and set interval notation, right? So the way that you do that, it's basically false. This would never work. But what you would do is that the empty set that we wrote last time was just 2 braces. Like it didn't exist. Okay. So when you do this, this would never happen. It's false, empty set. And that's what you call an empty set right there because it's empty. There's nothing in it. Okay. All right, so that's a quick one right there. We're going to do, we'll do compound. This is a good one too. So copy that down, pause it. We're going to go to example 4. And I'm going to show you compound inequalities right now. Okay. Compound inequalities, here's the thing. It looks funny. I remember thinking, this is actually really easy. This is actually super easy, right? But I remember students seeing that, and they were like so frustrated by it. They're like, why are you freaking out about this, right? So here's set A, negative 2, negative 1, 0, 1, 2, 3. Okay. And then set B is going to be 1, 2, 3, 4, 5. Okay. A intersection. Okay, yeah, that's what I meant. Okay. So now I was looking for the terms intersection and union. Okay. So we want to denote A intersection B. This right here means intersection. And then A U B, which is going to mean union. Yeah. Oh, you can barely see that. Okay, so what's going to happen is that A intersection means, this means A and B. All right. This is going to be either A or B. Okay. So when you write this, this says they want the set. Here's the original set. Okay. Set A is negative 2. This is the elements in the set. Negative 2, negative 1, 0, 1, 2, 3. For set B, these are the elements in set B, 1, 2, 3, 4, 5. Okay. Now, what we're going to do is that they want you to figure out, got to use the correct definition, correct terms, right? A intersection set B. So they want to know all the numbers that are in A and B. Okay, A and B. A intersection B, A and B. Okay, so you look at these right here. Look at set A real quick. You look at set B. Which numbers are in both of them? Okay, is negative 2 in there? No. Ones match up. 2's match up. And 3. So what you're going to do is you're going to write the elements of 1, 2, 3. Right there. Okay. Now, for the second one, you're going to have A or B. So you want to know all the elements that are in A or B. You don't double up either. You wouldn't write the same one twice. Okay. So it's basically, when you say A union B, what I imagine when I see this is if you extend these out on a number line all the way from end to end. Okay. So the elements would be negative 2, negative 1, 0, because that's in the first one. 1, 2, 3 still overlaps. 1, 2, 3, and then 4 and 5. Basically what it's saying is that what numbers in both of these sets are in either or. Okay, so you'd write out this is when you elongate. It's kind of like the domain almost, right? Because you want to know all the numbers that are in it. This one, intersection, you just want to know which ones are in both of them. Okay, you wouldn't put 4 because 4 is only in B, but not in A, and 5, and so on. Okay, so that is going to be that right there. I remember teaching that, and because students, it was new. It's not difficult, right? When you learn something new, you think it's difficult, no matter what it is. So it doesn't matter what in life you learn. If it's new, you're not going to like it. But this one's easy though. I don't know why students they're like freaking out over this. It was a really easy thing. Okay. All right, let's do it. Let's actually solve a compound inequality. I'm wasting paper over here, so let's try to use this right here. Okay, example 5 right here. Okay, so negative 3x minus 1 less than negative 4, or 4x plus 3. Yeah. So this is what we would call a compound inequality, okay? Compound means two, right? Obviously in science or chemistry, whatever you guys, like if you get a compound fracture, it's usually, it breaks the skin. It can break the skin, but yeah, I don't want to get into that because that's not a good look this early in the morning. But look up compound fracture or ask your A&P teacher what a compound fracture is and what are the technical definition of it. But compound in general for inequalities means two, okay? What we're going to do right now is we're going to solve both of these independently. I'm going to cruise right through this. So if you want to actually pause this and double check your answers, that would be really good. So you should pause it right now. Try to do these really quick, and I'm going to cruise right through them, okay? So, plus 1, plus 1. So it'll be minus 3, negative 3. Flip the fraction, so it's going to be 1, okay? This one's going to be 4x minus 9. We're going to go minus 3 here, minus 3 here. Divided by 4, divided by 4. It's a fraction. I don't know if that's correct. I think it's correct. So those are those two right there. Okay. Putting this on a number line, this would be 0, 1. Negative 9 over 4 is actually 2.125, negative 2.25. Okay, so we'll go 1, 2, 3. It's like right there. Yeah. So both of these are going to be open, right? Because there are no equal signs underneath it, right? And then x greater than 1 is going to go like this. X is less than negative 9 over 4 is going to go like this. Okay. So the interval notation for this is going to be x element. Let's go ahead and denote this first, okay? It's coming from the negative direction, so you're going to put negative infinity unbounded, open. And then you're going to put open on negative 9 over 4. Okay. And then for this one right here, it's going to be open at 1, going into positive infinity right here. Okay. Now I left this part blank right here because I want you guys to think. How do I say it's either on this side or this side right here? It's still up there if you look up there right there. I want to put either intersection or union. Okay. And here's the hint. We have or. See or right there? So what we're going to do is that union part for the notation is going to go right there. Okay. So answer right there. Okay. Now you're probably wondering like when would you put and that's a good question right there. When would you put? Why isn't it this one right here? Instead of going both ways, it's going to be in the middle. And I'll show you that one in a second. Okay. If it gives me one, let me see if it gives me one real quick. Oh, it doesn't give me one. Just remember or, okay? When you put or, it's going to look like that. And we'll look at a closed one right here. All right, last one real quick. Example 6. Move that over. We're going to solve 3x plus 5 and 3x plus 5. Okay, so it's 3x plus 5 greater than negative 13 and 3x plus 5 less than negative 1. So pause this one, try to figure these ones out on your own, and we'll go real quick on these. This is going to be negative 18 divided by 3 divided by 3x is going to be negative 6. And minus 5, 3x, minus 6. Okay, so we have those two right there. X greater than negative 6 and x less than negative 2. Now, it's an and. I already know what this is going to look like because it's going to be right. They're going to point at each other. Okay? Here's 0, 1, 2. Okay. Here's the thing. They're both open, right? Because there's no equal sign, so we're going to leave them both open. X is in the bigger direction is going to go this way. It's going to go to the right. In the less than direction from 2, it's going to go right here. So what's going to happen is you're going to have this. Now we could put, this is what I was talking about on the other page right here. We could put the domain for both of them and put an and in it, but it doesn't look proper. Okay, so what I meant was like, here's what it would look like if we were being not silly, but That was the wrong word. Okay, it would be unbounded 6 to positive infinity, right? And then this one would be negative infinity. That was positive infinity. And this one would be negative infinity, unbounded 2, right? And you would put this. Now, there's a better way to write that. We wouldn't write that as our answer, okay? So that would be that would be the elements of this set and this set right here, okay? But we don't want to write it out like that because that's very convoluted. While technically this is true, we can make this a lot easier right now, and you guys probably already see what's going to happen. We want all the elements that are within this set right here, but we're just going to open both of these and put 6 and negative 2. Because this right here is the same thing as this right here, okay? Because it's basically, see how those make it so they're kind of put together? We don't have to write all that stuff out, okay? So answer, 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 set interval notation, okay? So there are a lot more examples, but we're going to stop right there. But other than that, that's the quick hitter lesson. So hopefully you guys were able to pick up something from that. If you have any questions, go ahead and leave them below. And if you want to help me out, please like the video and please share it and tweet it and all that stuff. Okay. So other than that, I've been Justin. I'll talk to you guys soon. Bye.